All right, this is the section 5.1 inverse function pre-class notes. The main purpose of this specific section, we just want to determine if a function is what's called one-to-one using either a picture or graph and or looking at an equation. So when we first learned what a function was, we had the vertical line test because we were trying to prove that functions, each x is only used once. And we said it didn't matter if you had the same y. Now, to be a one-to-one function, you still have only each x being used once, but now we restrict it so that each y can only be used once as well. So a function f may have the same value for different numbers in its domain. For example, if f of x is x squared, we knew that 2 squared was 4 and negative 2 squared was 4, but 2 and negative 2 were not the same. To be able to have an inverse function, an inverse means you're going to take your function and work it in the opposite order. So you're going to be like starting with your y and moving back towards the x. You're doing the ordered pair backwards, essentially. Then you have to have this situation not existing because 4 can't map back both to negative 2 and 2 at the same time. So that's why we call a one-to-one function is one where each x is only used once and each y is only used once. So there's kind of a picture of what that looks like right here. Notice that each element in the domain, it only has one arrow coming away from it to an element in the range. So there's an absolute clear path backwards if you start at f of a and try to map back to a. Something that is not one-to-one, just so you have a kind of a counter to this, would be if we have, you still have to have each x only being used once or you're not a function. But what if you had, this one going to f of a, but let's say b also goes to f of a. So f of a and f of b are exactly the same point. Notice if you start at f of e or f of b here, f of e, I can't talk, f of a or f of b, if you try to map backwards, you wouldn't know which way to go. So that's why this one would not be one-to-one. Graphically speaking, this is what happens. If you have the same y value more than once, you will cross it more than once with a horizontal line. So the vertical line test tells us if we have a function. Remember, you drew vertical lines and each line could only cross the function once. The horizontal line test will tell us if our function, so it has to be a function already, is one-to-one. All right, so horizontal line test says if you draw horizontal lines, it will only cross your graph once per horizontal line if it's a one-to-one function. So when you're doing these, the first thing you do have to check is you have to make sure that these are even functions. So if you imagine drawing vertical lines, is this a function? Yes, this is a function. And then we would use a different color and do the horizontal lines. As long as each of those also only crosses that line once per line, then it is a one-to-one function. So this one is yes, one-to-one. Notice this first one this one right here. I'm going to go back to doing red for vertical line test. It passes the vertical line test, so it is a function, but it fails immediately that horizontal line test. It crosses it twice. So this is function, but not one-to-one. Let's look at this next one. It passes the vertical line test. Even though this looks like it's going straight, it's always kind of slightly curved here. And this one also passes the horizontal line test. Each blue line only crosses the function once. So this one is yes, one-to-one. So it's a function and it's one-to-one. The circle immediately fails the vertical line test, so this is not even a function. So you cannot be a one-to-one function if you're not a function. So let's look at the next one. Vertical line test passes for this, but the horizontal line test fails because you would cross it more than once when you go horizontally. So function, but not one-to-one. Now the next one is one that fails the vertical line test. It actually would pass the horizontal line test, but the reason we don't even do the horizontal line test is you have to be a function to even talk about a one-to-one function. So this one is just not a function. This passes the vertical line test, but fails miserably on the horizontal line test. Just look right here. It crosses way more than one time, so not one-to-one, but just a function. And then this one would have been good, except right here, it passes the vertical line test, remember, as long as it doesn't overlap with two closed circles. So right here we have a fail. So this is not a function. Now for this next piece, if you don't have a picture in front of you, it's a little bit harder for most students to figure out how to know if it's one-to-one. There's a proof. It's a pretty easy proof, but this is kind of the only proof we really show you in this class. We don't test you on this, but I want you to at least see how it works. If you want to show that a function is one-to-one and you don't have a graph in front of you, what we do is we assume that the y values are exactly the same. So f of a equals f of b. And then what we need to prove is that a and b are also exactly the same, because remember, we can't have two y values that come from two different x values. So if we can solve this showing that a equals b, then now we just want to be able to show, remember, like I said, that a equals b. So I need to show plugging this in for each of these. So 1 over a minus 2 instead of x equals 1 over b minus 2. I would cross multiply here, so that would be b minus 2 times 1 and a minus 2 times 1. If we add 2 to both sides, we actually see that b equals a. So that means that if we were to graph this, we would see it passes both the vertical and the horizontal line test. So this one is a yes. Now I wanted to show you one that fails, just so you think, well, that doesn't seem like you did much. Right here, if we assume that f of a equals f of b, that would give me a squared plus 4 equals b squared plus 4. And we would subtract 4 from both sides, and you get a squared equals b squared, not a equals b. To solve this, you have to take the square root of both sides. And when we take a square root, we have to write plus or minus, which means that we don't know if this is positive a equals positive b or positive a equals negative b. There's too many possibilities. It's not a clear-cut a equals b. So this one is a no. All right, and that's the end of this pre-video.